Hey, hi, hello. Hmm?
But class లో ఉన్నావా బయట కొరియర్ వస్తుంది పంపిస్తాను మధ్యలో టెక్స్ట్ ఇంటి పక్కన వస్తున్నారు వచ్చారు ఎవరైనా అదే అంటే మా ఏమగారు కలిసి తీసుకునే జాగ్రత్త వచ్చేసింది చిన్న అట్లా కాదు నాకు అడగాల్సింది దా పాస్లు ఎత్తి పెట్టుకున్నారు మా మళ్ళీ దాంట్లోనే తెచ్చుకున్నారు పార్సల్ వచ్చి వేసేది కాదు ఆ పార్సల్ ఎత్తుకొని వచ్చింది ఈజీగా ఉంటుంది ఏంటి అసలు రెండు చీరలే వచ్చినాయి మూడు చేసింది నేను అక్క ఏ కలర్ చెప్పు చేసుకుంది నాది కదా గ్రీన్
Hello.
Yeah, hello.
Hi,
Yeah,
sir.
hi. Red.
Sorry, I had a late lunch. Sorry.
Yeah, okay, no problem. So today, yeah, when is your physics CT?
Sir, 26th.
On 26th.
Oh, yeah.
Yeah, okay. Yeah, I think in the previous
Sir,
class. Yeah, tell
in
me.
physics, I had like couple of doubts. I finished like the first chapter. There are two chapters, right, in unit 5. So I finished the first chapter, but I had like couple of doubts. So shall I ask it in the next class, in the next physics class? Oh, but then CT is on 26th, right?
Yeah, CT is on 26th, right?
Right. Uh,
Yeah, okay, then we can
so can
start.
we do
Yeah,
physics
tell me.
today?
Yeah, we will do physics today.
Okay. So just give me 1 minute. I brought math instead.
Yeah.
నాది గ్రీన్ కలర్ కదా నాది గ్రీన్ పింక్
Yeah, so I had a question like in center of mass of a system of n particles.
Yeah. Yeah, today we are discussing the same thing. Yeah, in previous class, we just did about like how the forces will act on like this, right?
Right.
Now,
Oh,
today we will
sir, I'd
study.
also sent you vectors 1.2 worksheet. Did you get that?
Yeah, yeah, one point on that.
Okay.
I think you didn't do that. The third question. Okay, that
Third
one we will
question.
discuss.
Yeah.
Yeah, we'll discuss it afterwards.
Okay, sure.
So first, hmm. So in previous class we studied about the force and acting of the forces, right?
Hmm.
Where the force will act and all. So now let's see this. So in previous class we studied about there is a block and we are
Hmm.
applying some forces on it.
Right.
Correct?
Yeah.
Now where all these forces are acting, that one we have to know.
Okay. So
Okay.
that's the center of mass, right?
So all the forces are acting at one single point. They are
Hmm.
not only means we are considering all the forces that they are at the center of mass. Correct?
Right.
They are acting at the center of mass. Whatever the body it may be. So
Hmm.
any rigid bodies, all the forces that it acts, we are considering that it is acting at the center of mass.
Okay.
Okay.
Hmm.
Now let us understand what is this center of mass thing called. So center of mass is nothing. Let us suppose for a single body. First let us suppose a symmetrical body. Right?
Okay.
Let us suppose this is a square. And it is uniformly distributed. Uniformly distributed means, what is the meaning of uniformly distributed?
It's equal in
Yeah, uniformly
that.
distributed means the mass is equally distributed all over the body. Okay.
Okay. Okay.
So for uniformly distributed bodies, the center of mass will always be at the center. Okay.
Okay.
So now why we are studying the center of mass things and all? Because whenever we are studying, we are drawing about a triangle or a square and all, an equilateral triangle, anything it may be. All we are dealing with the symmetrical bodies. But what is the use of the center of mass when you are dealing with symmetrical bodies? This center of mass actually helps when we are dealing in rotation motion. Let's suppose there is some circle, right? A ball. Now we have to
Okay.
trace. There is means this ball is made up of a small particles, right? Which is on the top of it.
Right.
Now we have to trace this particle. So when the ball is rolling, if you want to trace this particle, it will be like this, right?
Right.
Means it is rotating and it is moving in linear motion. So for this type of conditions, finding the motion of this particle becomes very difficult. So then what we will consider is, we will consider a center of mass of this body and we will calculate this position of this particle with respect to center of mass. Okay.
Okay.
Whenever it may be, the position is fixed, right?
Right.
Suppose the body is over. So center of the position is fixed. The position is fixed. So if you trace this center of mass, it's always linear, right? For this system.
Yeah.
So if you want to consider the motion of this body, the center of mass will be here, and we will just see where the point is over here. Just we will point out like this. So for this type of conditions, this center of mass is very useful. Okay.
Okay.
So what we are doing is, we are calculating or we are tracing the path with respect to the center of mass instead of it tracing it alone. Okay.
Okay.
No. So here the center of mass formula first we will study for two bodies. Let us suppose there is particle M1, particle M2. Okay.
Okay.
So here all it depends upon the position that you are taking. Position in the sense, what is the position of this particle 1? What is the position of this particle 2? Okay.
Okay.
Now let us suppose I am considering this on a x-axis. This is at a distance of x1 from the origin. Remember.
Okay.
So now I am taking the reference as over here, right?
Yeah.
From here. Now this distance is x2 from the origin. So this is x1, this is x2. Okay.
Okay.
Now the center of mass always lies between the two bodies. Correct? It won't go outside.
Yeah.
Right?
Yeah.
So center of mass lies always within the body. Now the formula for finding the center of mass. We are finding the position of center of mass. Correct? This is at x.
Yeah.
So the position at x-axis of center of mass. The formula is m1 x1 plus m2 x2 upon m1 plus m2. This is the normal formula, and this is the basic formula which we will use for everything. Okay.
Okay.
So when they have given the positions, so x of center of mass is m1 x1 plus m2 x2 divided by m1 plus m2.
M1 plus
If you
M2.
want to make it as a generalized thing, so now we will represent this in a vector form. Let's suppose here it is m1, here it is m2, somewhere it may be. This vector is r1 vector. This is r2 vector, right?
Right.
Now we need to know what is the center of mass. Let us suppose center of mass will lie over here. We are calling it as RCOM. Okay. So that RCON, the same thing. We are making it generalized. R vector means it is in 3-dimensional thing. Okay.
Okay.
Means whatever the formula which is applicable to R, it is applicable to for all X, Y, and Z.
Exactly.
So here R center of mass is M1 R1, correct? And R1 is a vector, remember.
Yeah.
Plus M2 R2 divided by M1 plus M2. Means you are considering M1 and M2 as one single system. When both are at one single system, where will be the center of mass of that particular system? That one you are calculating. Okay.
Okay.
So the same thing as I told, if it is R XOM, same thing as X XOM mass M1 X1 plus M2 X2 upon M1 plus M2.
M1 plus M2.
Same thing with Y center of mass M1 Y1 plus M2 Y2 M1 plus M2. Same thing with Z. If it is 3-dimensional, Z center of mass M1 Z1 plus M2 Z2 upon M1 plus M2.
M1.
Maximum cases they will give in single direction or in 2 dimensions. If they give in 3, you have to find center of mass for each individual dimension separately. Okay.
Okay. Okay.
Now let's suppose here it is like this. There is a mass M. There is a mass 3m. Two particles. The particle of this mass is m. The particle of second mass is 3m. It is at 1, 0. Suppose 5, 0. Now we have to find what is the center of mass of this system. So when you are considering system means you are considering the both masses as one system. Means this whole becomes one total system. What is the center of mass of this system? Here there are only two bodies, so the set is nothing but center of mass between the two bodies. Correct?
Correct.
No. So what will be the center of mass for this? So first tell me what is the Y center of mass and what is the Z center of mass?
Both will be 0.
Both will be 0 because they are lying in one dimension, only in X. So now we need to calculate X center of mass. Correct?
Yeah.
What is the X center of mass? Just by using the formula.
M. Yeah. So M1 into X1 plus
X1
M2
is
X.
what is the X1? We will add the formula M2 X2 by M1 plus M2.
So that's M into 1.
Okay.
Plus 3M into 5 by M plus 3M, 4M.
So remember you are substituting here along with the signs because the signs tell us the direction where it is lying, right?
Okay.
So M1, so 3M. So it is M plus 3M. Okay. What you will get the answer as?
16 by 4, so 4.
16 by 4 m, so it is 4, right?
Right.
So means it is 4, 0, 0. Now tell me this 4 is from what you are measuring? From which point of reference? This is 4 centimeters or something. That is from this origin, right?
Origin. Okay. Yeah.
Means you can consider origin anywhere. So for this question, we are considering the frame of reference or reference point as origin. That is 0, 0, 0. From here, we are getting the answer as 4. Like here, right? 4, 0.
Yeah.
Correct? Here is the center of mass.
Okay.
So now here, just we can substitute M1, X1, M2, X2 depending upon this. From when they have given in coordinate system. What they give? The same problem as this. A particle of mass M1 of mass M. The second particle of mass 3M. The distance between them. is 4 meters. So then where will be the center of mass lie for this particular system? Here we don't know the coordinates, right?
Right.
So when you don't know the, as I told before, you can assume the origin anywhere. It's our wish. But the resultant means at the end, whatever you will get the answer, it comes from where we have assumed. So let us suppose we are assuming origin over here. Okay.
Okay.
Then what this point becomes? 3m.
Yeah. So that'll be 3.
So what it
0.
becomes? So 3 comma
3,
0. So now you know the coordinates, right? Directly.
Yeah.
So now we can just write what is that center of mass. So now tell me, what will be the answer
So
for this?
that'll be 3 into 3 by, wait, yeah, 3 into 3 by 4.
3 into 3
Is
by
that correct? 4.
4.
So it's 9 by
Tell
4.
me.
Is that correct?
It is 9 by 4. Let's see. This m1 into 0, it doesn't matter. So 3 into 3, 3. So it is 9 by 4. So 9 by 4 in the sense you are getting nearly as 2 point
2
something.
point. Yeah.
Right? Means when the
Yeah.
system is like this,
The center of mass
0,
is at.
it is 8, 10. So 2.25. Right?
Yeah.
Means 2.25 from mass m, from the origin. Means here we are assuming the origin is at m, right?
To be mass m, right.
So here, from here, it will be 2.2 means exactly at the center. So 2.25 over here. This is 2.25. From m till here is 2.25. That is the meaning, right?
Yeah.
So here the center of mass lies for the bodies. Okay.
Okay.
Wait, here I think we did one mistake. Both the answer should come as the same, right? Means the answer should come as 3. Why you are getting 2.25? Because the coordinate is 4 comma 0, not 3 comma 0. What is the distance between m and 3m?
Yeah, 4 meters, right.
It is 4 meters. So it is 4 comma 0. Correct?
Yeah.
Then you will get 12 by 4. That has 3. Correct? So 3 meters from
M1.
From m1. So here it is 3 meters. So now the same thing, if you want to measure from m2, what is this center of mass? Where the center of mass lies?
It'll be the same position, right?
Position is same, but you have to tell with respect to m2. Means you are considering this as 0 comma 0, this as minus 4 comma 0. Correct?
Oh, so minus 3.
Then you won't get minus 3. Calculate.
Minus 4 by minus 1.
You will get minus 1. Means minus is nothing but in the left hand side. On left hand side 1 centimeter or 1 meter. This is nothing but 1, right?
Yeah.
So it all, the position of center of mass, you will get answer depending upon where you are assuming the origin. Okay.
Okay.
So like in the questions, if you got one center of mass as one particular value as 3, but in the options we have 1, 2, 4, 5, then they are considering the center of mass from this m2.
the
So then 1
other
will be
side.
the answer. In general, they will mention like from M1 or M2 that we have to calculate. Okay.
Okay. Okay.
Now let us suppose this one. There are 4 bodies, which are the vertices of a square. Okay.
Okay.
M, 3M, 2M, and 5M. Okay.
Okay.
Let's make it simpler. 2M and 2M. Because with this, there is one shortcut that we have to use when the configuration is like this.
Okay.
So this is a square of side A. Now we need to find what is the center of mass for this system. System means it is a 4-body system, which is at the vertices of a square. Okay.
Okay.
So just what they give is this one. They have given the square vertices and the side A. Then we have to calculate. Here we don't know any coordinates, right?
Right.
So same thing, you can assume origin at any one body.
Okay.
Let's suppose you are assuming the origin over here. Okay.
Okay.
Then what is this 3M coordinates?
A, comma 0.
A comma 0. 2M.
That will be 0, comma A.
0 comma A. And M.
Again 0, A, comma 0.
A comma 0 is over here.
Right.
So now let's see. Here it is A in x-axis.
Yeah. Oh, A, comma A.
So this becomes A comma A. Now we know the coordinates.
Yeah.
Then we can calculate directly. So here there will be, it is 2-dimensional. So there you will get X center of mass and Y center of mass, right?
Right.
The formula is same. M1 X1 plus M2 X2. Here there are for 4 bodies. M3 X3 plus M4 X4. That's it. Okay.
Okay. Okay.
Divided by M1 plus M2 plus M3 plus M4. Same thing for Y. It just Y will come. Okay. Now when you see this, in general you have to calculate X center of mass by formula. By substituting you will get one value. Y center of mass, you will write the formula, you will get one value. Correct?
Correct.
Now we can limit the time, or we can take less time in calculation when we see the configuration of the system. Okay, first let's see over here. When you see the configuration, divide this actually at the center. Okay.
Okay.
Now, what is the mass, total mass on the left side?
4M.
2M and 2M, 4M. What is the total mass on the right side?
4M.
4M. Means this is symmetrical along this axis, right? Along 4M and 4M.
Yeah.
Means the center of mass lies exactly in the middle, correct?
Okay. Yeah.
Means in x-axis, so the x coordinate will be exactly at the middle. So total is A. This becomes A by 2. Correct?
Yeah.
Now just you have to calculate. If you want, see, we can say this 2, 3. So it is 3, 2, 3, 5. So here it is 3M, it is 5M.
Yeah.
Now we can't tell whether it is exactly at the middle. But when we are calculating, let us suppose, I think have you seen this normal balancing thing? Whenever if you go to buy fruits and all, here they will give the keep the weight, and here they will keep the fruits. In between you will see one needle, right?
Yeah.
So this needle tells whether this is the same as center of mass. This moves where the center of mass is. If both are equal weights, it is exactly at the center, right?
Yeah.
If this side weight is more, then center of mass inclines towards this side, correct?
Yeah.
Means center of mass will be nearer to the particle
Heavier.
which has, nearer to the
More.
heavier side. That's it.
Okay.
Simpler. Okay. Means center of mass will be nearer to the left side. If the mass increases, then the center of mass shifts towards the increased mass. Okay.
Okay.
So now for y center of mass, we can't just predict as it is. So just we have to calculate. So how to calculate this y center of mass? By using the formula. That's it, directly.
Okay.
We will get the coordinates as a by 2 comma, and whatever you will calculate for y, you will get that value. And somewhere it will lies over here. Right?
Yeah.
Because 3 to 5, it should be nearer to the heavier masses. That's why it lies over here. Okay. For n number of particles also, you will use the same concept. Just you will assume one particle's coordinate as origin. Then we will write all the different coordinates. Then we will just use the formula x, y. Same thing with z if it is 3-dimensional. Okay.
Okay.
So now, in this, the most tricky question just they will ask is, that one will just as into, when it is 2m mass and 4m mass. If you have to move 2m mass in such a way that the center of mass should remain constant. These type of questions they will ask. This one we'll discuss at the end of the class. Then you will get to know clearly. Okay.
Okay.
Now let's find what is the center of mass of an equilateral triangle. Mass m, m, m. They are asking find the center of mass of an 3-body system which are placed at vertices of an equilateral triangle. That's it. This is the question.
Okay.
Then how we will proceed?
Take any point as 0, 0. So origin.
Okay. This is A.
So that the next one would be a, 0. I mean 0,
Okay.
a.
Sorry. 0, a.
And the one above would be a, a.
It is y 0, a. This
Because
is
it's in the
x-axis, right? X-axis, it is moving in a direction.
Yeah.
So it is a, 0, not 0, a.
Oh, I see. Oh, sorry. I meant a, 0. Sorry.
Yeah, a, 0.
So
And
a,
what about this?
That will
The
be
top one.
a by 2.
A by 2 is
Because it's
exactly like here. Okay, here it is a by 2. So x-axis a by 2. Okay.
Yeah.
What about this height? Where it is in y-axis? That's the y coordinate.
I don't know how to like exactly find it out.
Actually, we have one formula. Otherwise, just we know trigonometry, right?
Right.
So here, let's see this. We need this height. This is a by 2, correct?
Yeah.
This is a, right?
Yeah.
What is the angle between them? Equilateral triangle, right? 60 degree.
Equilateral. Oh, yeah. Okay.
So then directly, we can get this directly.
Right.
This is the sine theta, right? Let's suppose keeping
Yeah.
it as D. So sine 60 is equals to opposite by hypotenuse, that is A.
Yeah.
So sine 60 equal, what is sine 60?
Root 3 by 2.
Yes, root 3 by 2, correct. Root 3 by 2 D. This is the height, that is the D. So
Yeah.
A comma root 3 by 2 A. Okay.
Okay.
Or in generally we have in maths, the height of an equilateral triangle is root 3 by 2 times of side. That is
Okay.
derived from this one only.
Okay.
Okay. So now you know the coordinates.
Yeah.
Now we can find directly. We know all the coordinates and we can find, and whatever it comes, you have to write it from this origin, that is 0 comma 0.
Okay.
This is the same formula, m1 x1, no need to calculate this. It's just calculation.
Okay.
Now the most important. They became in 3-dimensional. 3-dimensional also same thing. Let's suppose this is a cube. Okay.
Okay.
Now we have placed the particles of m2 m2 m. At the vertices of a cube. Okay.
Okay.
Now just we have to find what is the center of mass of this system. So for any center of mass, just if you know the coordinates, we can calculate very easily, right?
Right.
So just tell me the coordinates, because the calculation part is the same thing. What will be the coordinates for
Like, so what
this?
is the distance between
If they didn't give, it is a cube, so all are A. That's it.
A? Okay.
So first we are
So
assuming that m comma 1 as 0 comma 0 comma 0,
0.
since it is
Yeah.
a 3-dimensional.
Yeah. So the other one will be A comma 0.
Okay.
And
The
the one
top one
above.
is 0 A 0 in y-axis. So this one is
Yeah.
0 0 A. Now 2m 2m. Now tell me what is the vertices of this m.
That one. A0.
So this is in the xy plane, right?
Right.
So A and there is no z-axis, that's why 0. This is in yz plane. This one
0 AA.
0 A. This is in xz plane.
Right. So
So it will be
A0 A.
xz. Now only left out is this. This is in 3-dimensional, right? It is in all x, y, and z. So this is A. Correct?
Yeah.
Now we just have to calculate x1, y1, z1 directly.
Okay.
Okay?
Okay.
Now, here we have some important concept for center of mass for a 2-particle system. Because for n particle system, just we have to find the coordinates and we have to just calculate it by using the formula. or if there is if they are symmetrical to each other, then the center of mass will lie exactly at the center, right?
Right.
Now for this particular, let's suppose there are two bodies m1 and m2. It's at a distance of d. Okay.
Okay.
Tell me what will be the center of mass with respect to m1.
Respect to M1. So I'll be M2 into D.
So with respect to m1 means you have to this one 0, 0,
Yeah.
d,
And that will
0.
be D, 0.
It comes as m2d
2
upon
D by M1 plus M2.
m1 plus m2. This is with respect to m1.
M1.
No. With respect to m2,
So M1 into D by M1 plus M2.
m1d by m1 plus m2. With respect to m2 in the sense where we have assuming that the direction is this. That's why you're not taking minus.
Okay.
Keep this in mind. If you are taking direction directly as left side, you will get positive value. If you are taking this right side, then you will get as minus. How? This is 0, 0. This then becomes minus d, 0, right?
Right.
Then it comes as minus m1d by m1 plus m2. Okay.
Okay. Yeah.
Now let's see. This one and this one. Means from when you add this, so understood, right? How to calculate this m1 with respect to m1 and with respect to m2. Now, if I compare these two, m2d and m1 plus m2, m1d by m1 plus m2. Okay.
Okay.
If mass of particle m2 is more, then where the center of mass will lie?
It will be closer to M2.
It will be closer to
M2.
m2, right?
Right.
So let's see here. With respect to m1, this is m2d upon m1 plus m2.
Plus M2.
This one is m1d
Is
upon
M1 plus M2.
m1 plus m2, right?
Right.
Suppose I take this as r1, this as r2. Means this as r1 directly, this as r2. Okay.
Okay.
Now, can I write m1 r1 as m2 r2? Is it correct?
I don't think so.
Okay. What is r1? m2d by m1 plus m2, right?
Right.
I am multiplying with m1 with r1.
Oh yeah, yeah, yeah. It's correct.
m2
It's
is
correct. Yeah. It'll be the same
m2.
thing. Yeah.
Then both are the same.
Yeah.
So you have to remember this one. Means m1 r1 is equals to m2 r2.
Okay.
Suppose there is m1 over here, m2 over here, and there with center of mass, it can be anywhere. So we are taking this as r1 from mass 1, this as r2.
R2.
So then directly we can write, this is the relation between the position and the masses. Okay. So M1 R1 is equals to M2 R2. Okay.
Okay.
Now we will do formulas on this. So first, there is a metal rod of linear density. Okay.
Okay.
Linear density in the sense the total mass by unit area or unit length. So the mass per unit length is same. Okay.
Okay.
This is of total length L. Now we have to tell where will be the center of mass.
So we assume 1 point to be the origin.
Okay, 0, 0.
So the other coordinate will be L, 0.
L, 0. Okay.
Is it a unit mass rod?
Yeah, unit mass of mass M, let us suppose. M.
Okay.
M,
So that'll
L.
be ML by 2M, right? Center of mass.
ML by
2M.
2M.
Yeah.
So we are getting it as L by 2. So L by 2 means it is exactly at the center, right?
Center. Yeah.
Means for any uniformly distributed body. This is a rod. As I told, it is a uniformly distributed body, right?
Right.
For uniformly distributed bodies, the center of mass lies exactly at the middle.
Center.
That's why that is center. Anything. So center of mass is over here, L by 2. Okay.
Okay.
Now for a two rod system. This is of length L. This rod is also of length L. Okay.
Okay.
Now we have to calculate where will be the center of mass.
Okay. So the first, assuming the most left-hand side point is the origin.
Okay, if you consider by that way, then it becomes difficult.
Okay.
Because we don't know for writing the coordinates, then it will be difficult, right? For this one over here.
Yeah.
So that's why here what we will do is, there are 3 particles, okay?
Okay.
Now for calculating the center of mass for this whole system, what we can do is, first you can calculate the center of mass for these 2 bodies. You will get somewhere over here.
Oh, and then do it for the...
Then
okay.
with the position with the center of mass, then we will get somewhere over here, right? Means this is the final center of mass, correct?
Right.
We will follow this method over here, okay?
Okay.
So this method, in the sense, instead of bodies we have 2 rods, and we know they are uniformly distributed, so they will be at the exact center, right? That is the center of mass.
Yeah.
For this first rod, let's suppose this is exactly at the center, this position, this is L by 2, this is L by 2. So center of mass is over here, right?
Yeah. Yeah.
Now for this one, for the vertical rod. The center of mass will be over here,
Yeah.
right? Means
Yeah.
at a height of L by 2, correct? From the ground.
Yeah.
From the ground at the height. This is, let's suppose this is C1, center of mass for the first rod. This is C2, center of mass for the second rod. Now we have to calculate the center of mass for these two bodies. That's it.
Okay.
This is center of mass, right, at L by 2. So here it is at a distance of L by 2. These masses are same. This is also M. This is also M.
Yeah.
Actually, one thing I forgot to tell. What is this center of mass is all about, right? So center of mass means the mass of the total body is accumulated at one particular point. That is the actual meaning of center of mass. Correct?
Okay. Yeah.
Means the mass of the total body is accumulated at one particular point. We are calling it as center of mass. Means what is the mass of this point? It is M itself.
Right.
So the center of the mass of this particle is M. The mass of this C2 is also M.
M.
Right?
Yeah.
So this is C1, position of mass M. This is C2, center of mass M. Now we can calculate the center of mass for these two bodies. That is for these 2 point masses, right?
Yeah.
The distance between them is L by 2.
Yeah.
Because from ground, if it is L by 2, from the top also it is L by 2, right?
Yeah.
Now what is the center of mass when the distance is L by 2 for two symmetrical bodies?
It'll be half, right?
Half. So it will be L by 4, right? L by 4 from C1 or C2. We are calculating from C2 because we need height. So L by 4. If you calculate from C1 also, it will come L by 4 from the top. That's it.
Okay.
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 Means from this point at a distance of L by 4, right?
Yeah.
Now we have to calculate from the ground. From the ground. What is the height of this? This is L by 2 or so it is L by 2 plus
L by 4.
L by 4. Always when calculating center of mass, you have to tell with respect to the ground. Because it's a two-dimensional system, right? The ground is considered as a reference. That's it.
Okay.
Otherwise, they will give in the options. So you will get as 3L by 4, right?
Yeah.
So they will give the option. They will give 3L by 4 from ground, L by 2 from center of mass of rod 1, L by 2 from center of mass of rod L2. A, B, C. Now there are multiple options. So which are correct?
So the A would be correct.
A would be correct. Now if they give the same thing, D. L by 4 from center of mass of L1. So A, B, C, D, which are correct?
Again, A would be correct, right?
A is correct. B, C, and D.
Yeah.
D is also correct, right?
Oh. Yeah. But so you said you have to always take it from the ground, right?
Yeah. See, always take it from the ground. That's why they have mentioned over here from ground.
Yeah.
From center of mass of L1. You have to see the options of what they are asking.
Oh, okay.
Here they have changed the reference. Here changing the reference to center of mass of L1. You have to calculate from this perspective. Okay.
Okay.
They will change the options and they will give. Okay.
Okay.
Now just one concept. So what is this XCOM? Tell the formula.
M1 into X1 plus M2 X2 by M1 plus M2.
By M1 plus M2, right?
Yeah.
Now, I think, do you have an idea of differentiation as dx? When we will take dx? In the previous class, we studied about, while studying, I told delta x is represented as dx for small changes, right?
Yeah.
Means d is nothing but change, correct?
Right.
Dx represents the change in x, okay?
Yeah. Okay.
In general, d means differentiation. It is same as the change. You are measuring the change, okay? Now,
Okay.
dx of center of mass means change in center of mass, okay?
Okay.
Is nothing but change in the position of center of mass. That represents dxcom is m1 dx1 plus m2 dx2 by m1 plus m2. You have to remember this one.
Okay.
This formula is used for finding center of mass. All right.
Yeah.
This formula is used for finding change in center of mass. Okay. The difference between these two. There is 1 kg block, 2 kg block. Let's make it simple. 2 kg and 2 kg. The distance is 4 meters. Where is the center of mass?
Till at 2 meters.
At 2 meters. Right?
Right.
Over here. From, let's suppose, from this M1, from the first body. Okay.
Okay.
Now, second body is fixed. That is 2 kg is fixed over here. Now what I did is, I moved this first body in such a way. I moved this by 2 meters. Okay. Same 2 kg block, first one. Then what is the change in center of mass? Change in center of mass is nothing but what is its initial. What is in general change means final minus initial, right?
Right.
So final position of center of mass minus initial position of center of mass. Okay.
Okay.
So now let's calculate. We know this 2 and this is 2. Now the distance is reduced to 2 meters, right? Because I have moved this 2 kg block to 2 meters right side. So it will be at 1 meter from here.
Yeah.
Right?
Right.
Means from the initial position, if it is reference 0, 0, what is its position right now? 3, 0, right? No, from here.
Yeah. Yeah, yeah.
From here it is 1. So 2 plus 1, it is 3. Now, in initially, if it is 0, 0, it is 2, 0, right?
Right.
Now, what is the change? 3 minus 2. That is 1 meter. So, for finding this, if they have given directly, we can find directly. Otherwise, we can use this concept. Let's see how we can use this. What is this change in center of mass? What is the mass? M1 is 2 as it is.
2 kg. Yeah.
2 kg. dx1. dx1 represents the change in position of the first. What is the change in position of the first?
2 meters.
2 meters. So into 2 plus 2 for the second mass. What is the change in the second position?
There's no change, right?
There is no change. No change means 0
0.
by 2 plus 2. M1 plus M2, right?
Yeah.
So that is
So
4 by 4,
5, 1.
which is 1. It is same as this. Okay. Instead of doing the whole calculation, by just this formula, we can get what is the change in center of mass or change in the position of center of mass. Okay.
Okay.
From this concept only, we will arise what is the velocity of center of mass and what is the acceleration of center of mass from the same concept. Okay, just I will explain the same thing over here.
Okay.
Because it's the same. There is no difference. That's why. So first x is m1 x1 plus m2 x2 by m1 plus m2. Now when there is a change, as I told before, it is dx. Okay.
Okay.
m1 dx1 plus m2 dx2 by m1 plus m2. Correct?
Plus M2. Right.
Now remember, you have to do the differentiation with respect to the variables. Here x is the variable because mass is constant, right? The position may change. That's why you are keeping the differentiation for the variables, not for the constants. Now, if I differentiate this with respect to time, that becomes dx by dt, right?
Right.
It will become dx1 by dt, it becomes dx2 by dt. What is dx by dt? This is the center of mass. What is dx by dt? That is change in displacement by change in time. What is s by t? When we studying in
Velocity.
kinematics, velocity. This is velocity of center of mass. Velocity of center of mass is m1 v1. V1 is nothing but velocity of first particle. Okay.
Yeah. Okay.
dx2 by dt gives velocity of second particle, right?
Right.
By m1 plus m2. Understood how to find the velocity of center of, first we found out the position. Now we are finding the velocities. By just differentiating, we will get all. Okay.
Okay.
Now we will do differentiate this one. D velocity of center of mass. You will get m dv1 plus m2
Yeah. Plus
dv2.
M2 dV2.
Because velocities are variable, that's why you're doing constant. Now if you differentiate with respect to time.
Oh, then you'll get acceleration.
Acceleration. This is acceleration of center of mass.
Okay.
m1a1 plus m2a2 by m1 plus m2. That's it. Okay.
Okay.
This is same as the motion of the rigid body. Motion means you are finding the velocity, acceleration. Let's suppose there is any body. We are finding the center of mass for this.
Okay.
We are finding center of mass for this. Then we are calculating what is the velocity of this, what is the acceleration of this. Okay.
Okay.
That's why it's called motion of rigid bodies. Now, after all this, so from all of these formulas are arrived from only one thing, that is dx of center of mass is m1 dx1
dx1 plus
m2
M2
dx2 by
M1. M1 plus M2.
m1 plus m2. Okay. So what is this dx of center of mass? Change in center of
Change in
mass. That is change in the position of the center of mass. Okay.
Okay.
Now this question. Let us suppose there are two bodies. Like if 6 kg block is moved suppose 2 meters. towards right. Okay.
Okay.
By what distance? So this is first question. Next question will be center of mass changes. Now this is the configuration, the down one. There is 2 kg. There is 6 kg. Okay.
Okay.
And the distance between them, they didn't give. Okay. Just they gave
Okay.
this. So if 6 kg is moved 2 meters towards right side, by what
Right.
distance center of mass changes? Or center of mass will move. It's the same thing, right?
Yeah.
Now, how to calculate this one? Here we are calculating changing in center of mass, right?
Right.
When you have to calculate what is the center of mass, we have formula m1x1 plus m2x2 by m1 plus m2.
Right.
Now we have to calculate what is the change in center of mass. So what is the formula I told for changing in center of mass?
M1 dx1 plus
Means
M2
this
dx
d,
by
yeah, this change in center of mass is equals to m1 dx1 plus m2 dx2 by m1 plus m2. That's it.
Right.
Without knowing what is the distance between them, we can calculate directly. Right?
Right.
Are you using, let's suppose this distance r. Are you using this r in this formula? No.
No.
There is no use of it. Okay.
Okay.
Now calculate what is the center of mass for this.
1.5.
So let's see. M1 is 2 into what is this
0.
x1? 0.
0.
Plus 6 into
2.
2 by
Divided by 8.
8.
2 plus 6. So 8. So 12 by 8.
What is 2 plus 8? 12 by 8. So we got
8.
the answer.
Yeah. 3 by 2.
3 by 2. That is same as 1.5 meters. And you have to tell 1.5 meters which side. Whether it is going left or right. You have to tell, right? Previously, center of mass is over here. Now you have to tell. It's in left side or right side?
To the right, right?
Because it is plus.
Yeah.
Plus means always right side. So it moved towards right. Okay. Now for the same question. 6 kg block. Okay. I will write. So this is the normal 2 kg block. 6 kg block. This is the configuration. Okay. Same. If 6 kg block is moved 2 meters toward right side, by what distance instead of center of mass? 2 kg should be moved such that center of mass remains at same position. This is the question.
Okay.
No.
So can you just give me 1 minute, sir? Just 1 minute.
Yeah. Okay.
Sorry, sir. This. Yeah.
Actually. So now this one. So which formula you will use over here?
So the same formula, right?
So what is the formula?
So m1 dx is equal to m1 dx1 plus m2 dx2 by m1 plus m2. Except here
So-
you'll substitute the value of dx, right?
So dx1 is m1 dx1 plus m2 dx2
Dx.
by m1
m1
plus
plus
m2.
m2.
Okay, now tell me the values what you will substitute.
Dx is equal to 1.5
Why dx equal to 1.5?
from,
Read the question.
from the previous calculation.
No, that is different question. This is a different question.
No, so but like it says first if 6 kgs move towards the right?
So if 6 kgs move 2 meters towards
Towards
right.
towards the right. So
So
then
6
dx
kgs
would
moved
be
towards right.
yeah. So then dx would be 1.5.
Dx of center of mass is 1.5, right?
Yeah.
Okay.
So 1.5 is equal to 2 kg into dx1
Why dx1?
plus,
In previous case,
because we
dx1
don't,
is no. See this. What they give? If 6 kgs, read the total question. Don't break it to half. Okay.
okay,
If 6 kgs moved 2 meters towards right side, so we moved it 2 meters, okay, towards right side. By what distance 2 kg should be moved? So we have to move 2 kg whether this side or this side, such that the center of mass remains at same position. Means the center of mass should be here only. It should not change. What is the meaning of same position? Same position means it is not moving, right?
yeah,
If it is not moving, what is the change in center of mass position?
0.
0. So this is 0.
Oh yeah, it's changed, right? Okay.
Previously it changed to 1.5, but what we did,
Yeah,
it should remain at
no
same
change.
position.
So
Whether they can give
oh,
the center of mass remains at same position, that center of mass remains at rest, or there is no change in center of mass. They can use any like this. No change in center of mass. Any of these three they can use. The meaning is same. That is, the center of mass is not moving. That's it.
okay.
Means there is no change in center of mass. Understood?
Okay.
So 0 is equals to, the main substitution is this one, means substituting the center of change in center of mass is 0. This is the important thing, because the center of mass position remains same. That's why the change is 0. Okay.
Okay.
So 0 equals to m1, we have 2 into dx1 that we have to calculate,
Yeah.
plus m2,
Plus
6 into
6
dx2
into,
they gave as 2.
yeah, 2 meters.
Divided by m1 plus m2, it doesn't matter, because when it goes that side, it becomes 0.
Yeah. So 12 is equal to 2 dx1.
So 2 dx1 equals to minus 12, not 12.
Oh yeah,
Then
yeah.
plus 12
Sorry.
goes that side, it becomes minus 12.
So minus 12.
Because this plus and minus gives the position. That's it. That's why we are dealing with this. So dx1 equals to minus 6 meters. Means, what is the meaning of this
Towards the
minus?
left.
Towards
It
left.
moves 6 meters towards left.
Means you have to move this 2 kg towards left side.
6 meters. Yeah.
6 meters. Okay. This is the thing. Understood?
Okay. Yes.
So that's it. Whether it is n system particle, we have that formula. Finding x center of mass. m1 x1, m2 x2, mn xn divided by m1 plus m2 and so on up to mn.
2 each.
Okay.
Sorry. Yeah.
Yeah. Now the same thing with the velocity also is the same formula, right?
Yeah.
Now for
What?
acceleration also it's same thing.
Same.
No. Just one formula regarding this motion of center of mass when the velocities, when they gave the velocities. Okay.
Okay.
Now it is, let us suppose there are two particles. There is 1 kg mass. Okay. It is moving in this direction as
Okay.
5 meters per second. Then you have to find what is the velocity of center of mass.
Okay.
Means this is two-dimensional, right? You need x-axis and y-axis. That is the thing. That's it.
Right.
And they give this as 37 degree. This is velocity v as 5 meters per second. We need to calculate what is the velocity of center of mass. First, tell me what is the velocity formula for center of mass?
M1 V1 plus M2 V2, but there's no, yeah, M1 V1 plus M2 V2 by M1 plus M.
Here there is both M1. This is the only body that it is moving. 1 kg.
Right. So only M. Wait. So we
So
don't
M1 and
take
M1
M2
and
V2.
M2 both are 1 kg itself.
Oh, okay.
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 Otherwise, we will make it a bit complicated. Complicated in the sense by using two body system. That's it.
Okay.
Okay. Here there is 1 kg. It is moving in this direction with 37 degree with 5 meters per second. There is another body. Let's take it as 1 kg itself. It is moving like this with 10 meters per second. And the angle, let us suppose the same 37 degree. Okay. Now it is a two body system, right? There will be a center of
Right.
mass for this. If it is moving like this, then what is the center of mass for the whole system? Whole system in the sense, you have to consider that whole two bodies as one single system and you have to find what is the velocity of this, right?
Yeah.
Now, just you have to calculate. As I told before, whenever they give velocities in any angles, velocity, force, acceleration, whatever vector it may be, you have to make it into components. Okay?
Okay.
Because we have in x. Velocity will be in both in x and y axis, right? So velocity of center of mass
Right.
in x, it comes as v1 x1. Wait, where is it? So velocity of center of mass. So mass of first body into velocity of that body in x axis, right?
Yeah.
Plus m2 v x2 by m1 plus m2. Same thing we will get for velocity of center of mass in y. Mass into velocity of y in y axis. Velocity of y for first one. Velocity of y in second one. Divided by m1 plus m2. So you need what is the x components of both the velocities.
Right.
Now
So,
divide it into components for first one.
is X 4 and 3 and Y 3?
Okay, this is how much?
3 and 4.
Is it correct, right?
Yeah.
It is divided into two resultants. So this one will be
8 and 6.
8 and 6. Now we know all the components and something. So velocity of center of mass in x. Tell me.
So M1.
Both masses
so
are 1, 1.
Yeah. So 4
Hmm.
plus 8 by 4 plus 8. So it will be 1.
So it will be 1. Now for velocity of center of mass per second.
That'll be 3 plus 6 by, I mean,
Wait a
yeah,
second. Yeah, tell me.
yeah. Won't that again be 1 because it's multiplied by 1?
Why you are
Oh,
getting it as
wait,
1?
yeah. Sorry, yeah. I didn't realize. Sorry.
So center
So
of mass in
3,
y.
yeah. 3 plus 6 by 2
3.
plus
Yeah, tell me.
6.
1 into 3 plus
3
1
plus
into.
1 into 6.
You are taking just magnitude. Velocity is a
Oh,
vector.
minus, yeah.
It is in downwards.
Right.
Minus 6. See, if you
By
take plus 6, you will get different answer. That is wrong.
Yeah. Okay.
So it comes as
Minus 3
minus
by
3 by 2, which is minus 1.5.
1.5.
So this is along Vx, we have 6, right, meters per second.
Yeah.
Minus in the sense downwards, right?
Yeah. So 1.5.
1.5 meters per second. And how to calculate? This is represented in vector form. Velocity of center of mass equals to 6 I cap minus 1.5 j cap.
1.5 J, yeah.
But we need magnitude.
Right.
So what is the
square
magnitude?
Root of 6 square plus square of minus 1.5 the whole square.
That is 1.5 whole squares, right?
Yeah.
It comes
Yeah.
as 2.25. Okay.
Yeah. So root 38.25.
Root 38.25. That's it. Understood?
Yeah.
This is whatever concept you're using for positions, the same thing for velocities, accelerations. Okay.
Okay.
And for force also is the same, but there is one tricky or confusing concept in force. That one we will study it after. So first, let's suppose there is one question. There is a 10 kg block, 20 kg block. Okay.
Okay.
Now, by what distance this 20 kg block has to be moved? Okay.
Okay.
Such that the center of mass should be stationary when this 10 kg block is moved by 2 centimeters.
Okay.
Not the right question. So it's the same. By what distance this 20 kg block has to be moved such that the center of mass is stationary?
Right.
So which
So we
concept you have to
equate it
use?
with 0, right?
So first you have to write that formula, that is d.
Yeah. X is equal to
This is dx of
M1.
center of mass.
Yeah.
M1 dx1 plus M2 dx2 by
Divided by
M1
M1
plus
plus
M2. So this should be 0, right?
Yeah.
Not
So 0 is equal to 10 into 2 plus 20 into dx2 by 10 plus 20.
10 into 2. This 20 doesn't matter.
Yeah,
This 30,
exactly.
when it goes, that's what it becomes. So 20 equal 20 dx2 is equals to minus 20.
Yeah. So dx2 is equal to minus 1.
So what is the meaning of this?
It has to move 1 centimeter towards the left.
Left side, because it is minus. Okay,
Okay.
got it?
Yeah.
That's it. This is the regarding the center of mass. For finding whether it can be n particle, you know the formula how to find the center of mass, right?
Yeah.
For symmetrical bodies, always it lies between exactly at the center,
Center.
right?
Right.
Now, when they are asking that what is the change in the center of mass, you know what formula you have to use, correct?
Right. Yeah.
And when they are asking what is the velocity of center of mass, then also you know just the same pattern, right?
Yeah.
Means you have to remember only one thing, that is x is equals to, wait, what is the formula? m1 x1 plus m2 x2 by m1 plus m2.
By m1 plus m2.
This is x center of mass. With this, you can derive any formulas, correct? From the same
Yeah.
thing as y and z coordinates. And from the same thing, you can get the velocities and accelerations by just differentiating, right?
Yeah.
And from this concept only, we got that the differentiation of center of mass. If the the change in center of mass is 0, then we have to calculate the dx as 0. And that's it, right?
Okay.
And the one thing that we discussed way before, m1, m2, when they gave the relation between the positions and center of masses, when they gave like this, we have m1 r1 equals to
M.
m2 r2. Okay,
Okay.
that's it. This is in the center of mass. Next we have this force and all in this. That's it. Okay.
Okay.
Like in this, they are asking what will the in the next CT, are they giving like this boat problems type? Like what is the change in displacement of the boat? By what distance this boat moves left side when the person walks to the right side? Are they giving this type of
Okay. So
questions?
it's the same thing, right?
It's the same thing. So here what you have to do is, here the center of mass remains stationary in all the concepts.
Okay.
Whether the, so here just one thing is, you have to use that boat is moving x distance backwards. Okay. When the person moves, let us suppose the distance total is 5 meters. When he moves 5 meters, the boat x moves backwards at a distance of x centimeters. Okay.
Okay.
Next, you have to use the same formula, m1 dx1 plus m2 dx2 upon m1 plus m2
Plus m2.
equals to, directly you can make it to 0 because the center of mass is not changing.
This stage. Yeah.
That's why the dx, that is change in center of mass, is 0. Okay. Just to be in advance, I will tell how to do this if they give these type of problems in the exams. Okay.
Okay.
Just one question. But suppose there is a river and this is a boat. Okay.
Okay.
The length of the boat is 4 meters and a person is standing over here. Okay. Of weight 60 kg and the boat weight is 40 kg. Okay.
Okay.
Now in this, remember, for these questions, the observer is on the ground.
Okay.
Okay. Means you have to calculate all with respect to the ground. That is the meaning.
Okay.
So means with respect to the ground. Okay, that one we will calculate. Let's see now. So the actual question is, when this person moves from one end to the other end, means he is moving in this direction to the other end. Okay.
Okay.
Then by what distance the boat will move? Okay. That is the question.
Okay.
That's it. Because obviously we know when a person is moving towards right side, the boat will move towards back side.
Yeah.
Okay.
Okay.
So here you are taking is the change in center of mass as 0. Okay.
0.
Because for the whole thing, the change in center of mass is 0.
0.
No. So tell me what will be 0 is equals to the masses. It doesn't matter in the denominator, because when it goes that side, it becomes 0.
So 60 into x dx.
60 into, just you need to know what is the change it did, right?
Yeah.
Then it becomes dx1 and dx2. We don't know both.
Yeah,
Right?
both. Yeah.
That's why. So just listen to this. I know this as 4 meters, right?
Yeah.
Means he moved a total of 4 meters with respect to the boat. Correct?
Correct.
But the boat moved backwards with x meters, right?
Yeah.
So in general, as when with respect to ground, we have to take it as a relative velocity, relative distance. Means he moved total of 4 minus x meters. Because 4 meters right side and the x,
Yeah.
the boat
X meter.
moved towards left. That's why it is 4 minus x meters. Right?
Okay. Yeah.
This is the change in distance, right? So he moved
Right.
from this position to this position. He moved from this position to here.
Yeah.
So that while moving that, the boat also moves backwards with x meters. But we
Okay.
have
So
assumed.
will it be 60 into 4 minus x plus 40 into x?
Yeah, 60 into 4 minus x plus the 40 into what is the boat?
Yeah.
Where it moved?
X centimeter.
X. But which side? Left.
Towards
That's
so
why
minus
minus
x.
x. You have to see along with the direction I told. Okay.
Yeah. Okay.
That's it. Divided by whatever it may be. Whether it is 60 by 40, it doesn't matter, because we have 0 on the other side.
Okay.
That's it. This is the way, from this concept we will get what is the value of x. That is, the boat moved this much of distance. If you calculate, we will get as 60 minus 40.
So is it 2.4 centimeter?
Yeah, we got it as
2.4 centimeter.
yeah, 2.4, and it is plus.
Yeah.
Right? The meaning of
Yeah.
this plus, see here. The meaning of plus means it's not right side. The meaning of this plus means what we assume direction is correct. That is the meaning over here. Okay.
Okay.
We assumed it is moving left side, and we are getting
Yeah.
the same sign. Means the assumed direction is correct.
Correct.
So it moves 2.4 meters left. That's it. This is the way for doing this type of questions. Okay.
Okay. Yeah.
And any question like whether there is a boat, river, or they give like this frictionless pulley, and there is a person starting over. If he moves this side, what is the distance that the trolley will move? The same concept, right?
Same thing. Yeah.
Just you have to know this one. Means you have to calculate with respect to the ground. If it moves x, let us suppose it is 8 meters. So total is 8 minus x. Okay. Right. Here it is minus 8 plus x. Minus 8 in left side, right? That's why minus 8. X in which direction? Right side. That's why minus 8 plus
Yeah.
x.
Plus
M1 into minus 8 plus x plus M2 into x,
M2
because the
into
x is in right direction.
Yeah.
Is equals to 0. From this we will get what is the value of x directly. Okay.
Okay.
That's it. These are the maximum cases you got. Next we have this moment of inertia. I think they won't ask the questions for now.
Okay.
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 Okay then.
Okay, sir.
Okay then. Bye.
Okay. Thank you, sir. Bye.
Yeah.